According to the National Electrical Code, specifically Article 350.10e, flexible cords and cables shall not be used where they will be subject to manipulation in service. Additionally, Article 350.12b states that flexible cords and cables shall not be concealed within walls, ceilings, or floors. Using SJ cord, which is a type of flexible rubber cord, inside of conduit is a violation of these code requirements. The reason it is a violation is firstly, the cord is subject to manipulation in service. When the SJ cord is run through conduit, it is possible for it to be pulled or moved or otherwise manipulated, which directly contradicts the NEC guidelines. Secondly, the cord becomes concealed within the conduit. Concealing flexible cords and cables in this way is prohibited by the NEC. The NEC is in place for electrical safety to ensure proper methods and materials are used for electrical installations. It's important to use the correct wiring methods in order to ensure electrical safety and to avoid potential fires or electrical shock hazards. A better and proper method to install electrical wiring inside a conduit is to use individual conductors such as THHN wires. THHN stands for thermoplastic high heat resistant nylon coated wire. THHN wires are specifically designed for use in conduit and raceways. They are suitable for both wet and dry locations and have a high heat resistance rating. To properly install electrical wiring in a conduit, you would start by running the empty conduit between the desired locations, such as from a junction box to an electrical panel. Then, you would pull the individual THHN wires through the conduit. It is important to use the correct size and type of THHN wire for the specific application and circuit requirements. Once the THHN wires are pulled through the conduit, you can terminate them at both ends using appropriate connectors and terminals. It is important to follow all applicable electrical codes and safety guidelines when working with electrical wiring. When terminating the wires in an electrical panel, ensure that the panel is de-energized to prevent electrical shock. Connect the THHN wires to the corresponding circuit breakers or terminals, making sure to tighten all connections securely. If terminating the wires in a junction box, use appropriate wire connectors to join the THHN wires to other wires or devices. Make sure to properly ground all electrical components and equipment according to the NEC and local electrical codes. Grounding provides a safe path for electrical current in the event of a fault, helping to prevent electrical shock and equipment damage. Always use the appropriate tools and equipment when working with electrical wiring, such as wire strippers, pliers, screwdrivers, and voltage testers. These tools are designed to make electrical work safer and more efficient. When working with electrical wiring, it is important to wear appropriate personal protective equipment, such as safety glasses and gloves. This will help to protect you from electrical shock, burns, and other injuries. If you are not familiar with electrical wiring and installation procedures, it is best to consult with a qualified electrician. A licensed electrician has the knowledge, skills, and experience to safely and properly install electrical wiring in accordance with the NEC and local electrical codes. Improperly installed electrical wiring can create a fire hazard or electrical shock hazard, so it is important to ensure that the work is done correctly. Remember that electrical codes and regulations may vary depending on the location, so it is important to consult with local authorities or a qualified electrician to ensure that all work is in compliance with applicable codes. Regular electrical inspections can help to identify potential electrical hazards and ensure that your electrical system is safe and up to code. It's also important to consider ampacity when selecting conductors and installing wiring. Ampacity is the current carrying capacity of a conductor, and it is determined by the size and type of wire, as well as the ambient temperature and other factors. The NEC provides tables and guidelines for determining the appropriate ampacity for different types of conductors in various applications. When selecting conductors for a specific circuit, it is important to ensure that the ampacity of the conductors is sufficient to handle the expected load. Using undersized conductors can cause overheating, which can lead to insulation damage, electrical fires, and equipment failure. It is also important to consider voltage drop when installing electrical wiring. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the wire. Excessive voltage drop can cause equipment to operate inefficiently or to fail altogether. The NEC provides guidelines for limiting voltage drop in electrical circuits. To minimize voltage drop, it is important to use conductors that are large enough for the length of the circuit and the expected load. It is also important to avoid long runs of wiring and to use high-quality conductors with low resistance. In addition to THHN wires, there are other types of conductors that are commonly used in electrical wiring, such as THW, XHHW, and UF cables. THW stands for thermoplastic heat and water-resistant wire. It is similar to THHN wire, but it is designed for use in wet locations. XHHW stands for cross-linked polyethylene high heat-resistant water-resistant wire. It is a type of insulated wire that is commonly used in underground applications. UF cable stands for underground feeder cable. It is a type of cable that is designed for direct burial in the ground. The type of conductor that is used for a specific application will depend on the specific requirements of the circuit and the environmental conditions. It is important to consult with a qualified electrician to determine the appropriate type of conductor for your application. In addition to the NEC, there are other standards and guidelines that may be relevant to electrical wiring and installation, such as those published by the Institute of Electrical and Electronics Engineers IEE and the National Fire Protection Association NFPA. These standards and guidelines provide additional information and recommendations for safe and efficient electrical installations. It is important to stay up to date on the latest codes, standards, and guidelines to ensure that your electrical work is in compliance and that you are using the best practices for safety and performance. In summary, sleeving SJ code through conduit and into a panel is a code violation according to the National Electrical Code. The cord is subject to manipulation in service and concealed within the conduit, which violates NEC guidelines. The proper method is to use individual conductors like THHN wires pulled through the conduit and terminated in a junction box or panel, ensuring electrical safety and code compliance. Always consult with a qualified electrician and adhere to local codes and regulations for safe and proper electrical installations. When working with electrical wiring, it is crucial to prioritize safety and follow all applicable codes and guidelines. This includes wearing appropriate personal protective equipment, using the right tools and equipment, and ensuring that all electrical components are properly grounded. By adhering to these safety precautions and code requirements, you can help to prevent electrical fires, shocks, and other hazards. It is also important to remember that electrical work can be complex and dangerous, so it is always best to consult with a qualified electrician if you are unsure about any aspect of the installation process. A licensed electrician has the knowledge, skills, and experience to safely and properly install electrical wiring in accordance with the NEC and local electrical codes. In addition to safety, it is also important to consider the efficiency and performance of your electrical system. Using the right types of conductors and wiring methods can help to minimize energy losses and improve the overall efficiency of your electrical system. It is also important to ensure that your electrical system is properly sized to meet the demands of your electrical loads. Overloaded circuits can cause overheating, which can lead to insulation damage, electrical fires, and equipment failure. By properly sizing your electrical system and using energy-efficient components, you can save money on your energy bills and reduce your environmental impact. Another important aspect of electrical wiring and installation is proper labeling and documentation. All electrical circuits and components should be clearly labeled with their function and voltage rating. This will help to prevent confusion and ensure that the correct circuits are energized when performing maintenance or repairs. It is also important to keep accurate records of all electrical work that is performed, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be invaluable for troubleshooting problems and ensuring that the electrical system is properly maintained over time. Finally, it is important to remember that electrical wiring and installation is an ongoing process. As your electrical needs change, it may be necessary to add new circuits or upgrade existing ones. It is also important to regularly inspect your electrical system for signs of wear and tear, such as frayed wires, loose connections, and damaged components. By performing regular maintenance and making necessary repairs, you can help to ensure that your electrical system remains safe, efficient, and reliable for years to come. In addition to the points already discussed, let's consider some common mistakes to avoid when working with electrical wiring. One common mistake is using the wrong size or type of wire for a particular application. As mentioned earlier, it is crucial to select conductors that are appropriate for the current carrying capacity and voltage drop requirements of the circuit. Using undersized wires can lead to overheating and potential fire hazards, while using the wrong type of insulation can result in premature failure or electrical shock hazards. Another common mistake is improper grounding. Grounding is a critical safety feature that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Improper grounding can render this safety feature ineffective, putting people and equipment at risk. To ensure proper grounding, it is essential to follow the NEC guidelines and use approved grounding methods and materials. A third common mistake is making loose or improper connections. Loose connections can create resistance, leading to overheating and potential fire hazards. Improper connections can also result in electrical shorts or open circuits, causing equipment to malfunction or fail. To avoid these problems, it is essential to use approved connectors and terminals and to tighten all connections securely. A fourth common mistake is neglecting to protect wires from physical damage. Wires that are exposed to sharp edges, heavy objects, or other potential hazards can be damaged, leading to insulation failure and electrical shorts. To protect wires from physical damage, it is essential to use conduit, raceways, or other protective measures. A fifth common mistake is failing to properly label circuits and components. As mentioned earlier, clear labeling is essential for preventing confusion and ensuring that the correct circuits are energized when performing maintenance or repairs. Failing to properly label circuits can lead to accidental shocks or equipment damage. To avoid this problem, it is essential to use permanent labels and to update them whenever changes are made to the electrical system. A sixth common mistake is working on live circuits. Working on live circuits is extremely dangerous and can result in severe electrical shock or death. To avoid this risk, it is essential to de-energize all circuits before working on them, and to verify that they are de-energized using a voltage tester. Finally, it is important to remember that electrical codes and regulations are constantly evolving. To ensure that your electrical work is in compliance with the latest requirements, it is essential to stay up to date on the latest codes and standards. This can be done by attending training courses, reading industry publications, and consulting with qualified electricians. By avoiding these common mistakes and staying informed about the latest codes and standards, you can help to ensure that your electrical work is safe, efficient, and compliant. Furthermore, let's delve into some advanced considerations for electrical wiring and installations. One advanced consideration is harmonic distortion. Harmonic distortion is a phenomenon that can occur in electrical systems due to the presence of nonlinear loads such as electronic devices and fluorescent lighting. Harmonic distortion can cause a variety of problems, including overheating of transformers and conductors, equipment malfunction, and interference with communication systems. To mitigate harmonic distortion, it is essential to use harmonic filters or other mitigation techniques. Another advanced consideration is power quality. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can cause a variety of problems, including equipment malfunction, data loss, and premature equipment failure. To improve power quality, it is essential to use power conditioning equipment such as surge suppressors, voltage regulators, and uninterruptible power supplies. A third advanced consideration is energy management. Energy management is the process of monitoring and controlling energy consumption to reduce cost and improve efficiency. Effective energy management can involve a variety of strategies such as using energy-efficient equipment, optimizing lighting and HVAC systems, and implementing demand response programs. A fourth advanced consideration is renewable energy integration. Renewable energy sources, such as solar and wind power, are becoming increasingly popular as a way to reduce reliance on fossil fuels and lower energy costs. Integrating renewable energy sources into an electrical system requires careful planning and design to ensure that the system is safe, reliable, and efficient. A fifth advanced consideration is smart grid technologies. Smart grid technologies are a set of advanced technologies that are used to improve the efficiency, reliability, and security of the electrical grid. Smart grid technologies can include smart meters, advanced sensors, and communication networks. A sixth advanced consideration is arc flash hazard analysis. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails, resulting in a sudden release of energy in the form of heat, light, and pressure. Arc flash can cause severe burns, blindness, and even death. To protect workers from arc flash hazards, it is essential to perform an arc flash hazard analysis and to implement appropriate safety measures, such as wearing personal protective equipment and using arc-resistant equipment. These advanced considerations are just a few examples of the complex issues that can arise when working with electrical wiring and installations. By staying informed about these issues and consulting with qualified experts, you can ensure that your electrical system is safe, efficient, and reliable.